this time I have a little bit more preparation than the last time I gave the class here, but it's still like kind of improvised, so we'll see how it goes. I want to talk about IDEs and compilers, and to do that, I'm going to do something I've decided that really works well in talks, is to first introduce like what I mean by a compiler. When I talk about the Scala compiler, what is it actually? This is like the pipeline of the Scala compiler, as most people probably think of it. Like it takes some Scala file as input, then there's something that happens, and then you get class files as output. And so you probably know what the first thing that the compiler actually does. It's actually going to parse your code. And I think it's worth taking a few moments to explain what parsing is, because I'm going to talk a lot about trees, and to know what I'm talking about is good if we know like what these trees actually come from and what they are. So imagine that you write some code like foo.lm of 5. What does the compiler do when it sees that code? So it's going to read it left to right, and so it sees this thing which is called foo, and it's going to make a tree node for it. So tree is basically a trait with, it's an ADT with a bunch of case classes for every kind of tree node we have. So like foo is going to be an identifier, and then when you do dot, how do I unzoom? Perfect. So when you do foo.lm, then the parser sees, oh, well, there's a dot here, so this is a selection. So I'm going to represent that with a tree of type select. And the tree of type select takes two things. One of them is the thing you're selecting from, and the other is basically what you're selecting. So far, so good. And then we do the application, and again, that's a tree node for applying things. So that's parsing, basically. Okay, so once you've done parsing, what's the next thing you do? Type checking. So we have this phase, we usually call it the typer, and what it does is it takes this tree, which doesn't really have any semantic meaning, and it's going to add little types information to every tree node, so we know if the program type checks. So I'm not going to run through this. I have an example, but I'm going to run through it in details, because I have another talk I gave last month at Scala World, where I explained type checking and type inference in details. So, and it's not so relevant here. So what I'm just going to say is that to type check, you start from the top. You see this apply node, and to type check the apply node, well, you need to know what you are applying to what, so you need to type check the select node, and when you do that, you need to remember that whatever you are doing here is something that needs to be applied, so this thing here is the expected type, and then you keep going recursively, and then you go back up. And there's some tricky issues involving overloading and singleton types and stuff like that, but what matters is, in the end, you get a type for your expression. Okay. Now I want to talk about the IDE pipeline. So what I showed so far is like how a regular compiler works, and there's still some magic here that I haven't explained that in the end gives you a class file. But for an IDE, you don't really care about that. For an IDE, you care about the fact that there's some editor here that's going to actually be used to write your code, but you're not trying to produce class files, you're just trying to write code in your IDE. What you do care about is that from the type checker, you have some feedback loop that goes into your IDE and tells it, oh, you made an error here, or that kind of thing. And of course, you don't really want to tie the type checker directly to the editor, so there's usually a box in between, which these days is usually called the language server from the LSP protocol. So there's one interesting thing here is that this arrows goes into both directions, because not only do you need to tell the type checker, the language server about, say, errors, and then the language server tells the editor about errors, but you also need to be able to do things like go to definition, which involve the editor asking the language server, hey, can I go to the definition of this thing? And the language server then has to, either it has cached the information, or if it doesn't, it can like ask the compiler, type checker, like, where is the definition of that thing? And I gave a talk 1 year ago at here, where I talked a bit about the infrastructure of the Dotty language server as it stands right now. So I'm not going to go too much into details here. Yeah, and here basically, like, all of these boxes and all of these edges are interesting, because like, there's a lot of things, a lot of design decisions here, but the one box I'm interested in here is missing. It's this one. But really, we are not just, this isn't just a closed feedback loop. There's an actual human who's trying to communicate with the compiler through this elaborate contraption involving editors and parsers and JSON and whatever else. And I think we are still at a very primitive stage in development, in programming, where these interactions are not very evolved. Like most of the time, you type stuff in your IDE and then like you get a bunch of red lines everywhere. And so there's ways to work around that. I think the most interesting one, I want to mention that, is this thing the IntelliJ folks did of a functional highlighting. Hi, Pavel. So if you haven't seen this, I think this is like the best innovation in IDEs of like the past, the recent years. So yeah, what usually happens is you write some code, and then like something doesn't type check, so then well, the compiler tells you, well, all of this stuff, really, this is wrong. Like, well, this is completely wrong. Of course, the types don't match, and this isn't really nice because this is mostly noise or this red stuff. So what the IntelliJ people did is they said, well, we don't actually want to show you all of that. Instead, we're going to add a little type information here. And this basically tells you what the expected type is supposed to be, and the part in red is the part that is wrong. So here you see, oh, you wrote an expression whose type is hashmap in Boolean, but actually you need a map of int or string. And instead of cutting the whole expression, which might be multiple lines, as in red, they just added the information here. And I think that's brilliant. And actually, that's one thing which is hard to do with both VS Code in particular and the language server protocol in general, because the language server protocol can be used to send diagnostic information. So you can send, oh, at this line I have this error, but you don't have any semantic knowledge that, oh, this is a type error and it means this or that. So it's hard for the IDE to display it properly. And even if you hack something, like I looked into it, and I don't think VS Code can have something as nice where you can have a little, like, not really text that you add, and then you add a little underline here. Like you can add some text decorations, but they're not that developed. Anyway, so before I go further, like just to give some context, so this is just an example of the kind of things I'm interested in, but to give some context, there was this talk 3 years ago by Guy Steele, the guy who made Scheme and Fortress and a bunch of other things. How do we tell a compiler what we think we know? And so the talk is very interesting, and unfortunately I don't think it's been recorded. But there's slides online which kind of give you the idea, which is the idea should not just be like something where you talk about, you use types and the compiler tells you your types are wrong. Like, what Guy Steele said was you want a conversational partner that can keep track of what you're doing, can react to what you're doing, can give you relevant information based on context. Okay, so that's the goal, that's like the dream, but of course we're not here yet, but there's some things we can do. Okay, so I want to talk about typed calls. And this is the part where I start doing live coding and things go horribly wrong. So when you're typing code and are things going wrong already?
Save?
I'm not using meta. One sec. Saved. Okay. So you're typing some code, and then because your expression is incomplete, then the parser freaks out, and you start getting a bunch of errors everywhere. So how do you avoid that? The easiest thing to do is just like add 3 question marks. And that's actually one way to write code is just start writing your definitions and your types, and then just put 3 question marks where you don't yet have code. And the main drawback of this approach, I think, is then when you run your code and everything explodes. Which of course makes sense because you put the 3 question marks in here. But what we usually want is not to run the code with the 3 question marks, but just to say, oh, this is a placeholder and I'm going to fill it later. So there's this concept that I think comes from Agda and was then imported into Haskell and then IDEs, and there's a Scala compiler plugin too, where basically you write a typed word. So here I'm going to call it A. And when you write this A, then this is like the compiler sees that pretty much like the same way it sees 3 question marks. It's a thing that can have any type except when you put that thing here, you also get an error message which says, oh, I found a hole with this expected type. And here are the things you can do to fill this hole. So if I declare something else of type int, here it's going to tell me, oh, well, you could use the variable z of type int to implement this hole. And in the end, if I put z, then everything compiles. And so this gets interesting, of course, when you have more complicated types. Like if I do list 1, 2, 3, map f, then f needs something of types and int to b, where b can be anything. And here it tells me where you don't have any relevant thing. But if I had any function anywhere that had some type, say int to string, then you should be able to pick it up. It doesn't here, but ignore that. That's just part of the show. But so the idea here is like anything in scope or anything from your imports, you can easily, like for the compiler, it's easy to find this and then to tell you about this. And this means you can like start writing your code, put a bunch of holes in the places where you're not sure about, and you will get less red underlines because you will only get the red underlines on the holes themselves, but the rest of the program will be correctly parsed. So the compiler will be able to make sense of it. And at the same time, the compiler will also be able to give you some more information on what you can fill this hole with. So this actually already exists in Scala because someone, Chris Birchall, made a compiler plugin, or is it a macro? I think it's a compiler plugin for ScalaSphere, which implements something like this. But I did this experiment of adding this to Dotty and actually going a little bit further. So I think one interesting thing to try is like what happens if you use the same hole in multiple position. So that means that we need to replace $f by something whose type, which is going to type check in both of the situations. So do you know what type $f should have?
Any two units. Any two something.
Yeah, except this is Dotty, so we have union types. So you can actually say, well, actually the constraints, the only constraints you have is you need a function that goes from int or string to something. And this knowledge is something that the compiler can very easily give to us because this is the exact same kind of constraints that the compiler has to solve to do type inference. And I have this other talk on type inference if you want more details. But this just gives you an idea of the interesting things we can do when we start trying to get some way to, so the compiler has all this knowledge about types and our programs, and very often we only see this knowledge through error messages, which are like very sometimes hard to decipher, but with some work, I think we can make it easier to extract this knowledge from the compiler. So after I did this, I said, well, actually sometimes I don't have a term, but I want to know what a type is. So say I do, let's see if I do it correctly. If I have a list buffer of 1, then I try to add a string to it, well, I'm going to get an error because list buffer is invariant, and I'm trying to add a string to it, and I can only add an int to it. So what I did was, well, maybe we can have like typed holes, where you say, oh, I don't know yet what this type is going to be. So just like keep this unconstrained, or constrain it based on what you see, and then accumulate the constraints. And here it gets, I don't know how to do the user interface really, because I don't know where to put the information. So now I put it just at the last line, which tells me, oh, A has to be a supertype of 1 or the empty string. So those are the singleton types, which is why it's so precise. So that's all the information you need. So I think that's interesting because, like, of course, Scala has only local type inference, and you're not supposed to be able to do these things. But if we just tell the type checker, well, Python, you can do global type inference, then well, it can do it for you. So this was really like not much lines of code to actually do something like that. Another interesting thing is if I do f.length, and I need to use another name, of course, then here we expect. I probably should give it a type. Yeah, so I say I want something which has a method length whose type is int, and here actually the type checker, when it type checks things, it takes this kind of information into account. So here it can tell us, well, you're looking for a type which has a member called length, and then it can easily like go through all your imports and stuff and find any method that can return something of a type which has a member called length. So this is kind of like a reverse completion. In fact, we could probably like easily make it so that you could do tab completion when you type this, and does find all the possible members which have a length method, which I think is funny. Okay, back to the typed holes, because there's one more example I wanted to show. So there's this thing in Scala which has always frustrated me. It's like, do you know that thing? Do you see where I'm going? You type that, and you want to reverse the list, and instead you get blah, I found a list of int, I required nil. So the problem is this thing gets the type nil, because when you type check the fold, first argument of the fold is of type B. Let's see if we can see better. First argument of the fold is of type B, and then the second argument is a function that takes B and A and returns a B. So the function, to type check the body of the lambda, we need to know the type B. But all we know at this point is that it has to be a supertype of nil, so we just pick nil. And then we fail because that means that we need to return nil. Okay. So then, what if we put a type for in here? And just to show you, I can see that then x, and then we do, should be a list of int, right? Yeah, close enough. So it's telling me that x has to be something between a list of int and a list of underscore. So what I did here is I, instead of instantiating the type parameter of foldleft to nil, I just said, well, this is a whole, like only accumulate constraint, don't solve them. And then you just need to do a trick when you get to type checking the body, because here you have this current column. So my idea, the heuristic I'm using here is like saying, okay, well, nil has a method called colon. This method is an override from the current colon on list, or it's maybe not even overridden, but it's defined on list. So that means that if I want to be able to call colon, I need as a constraint that ACK has to be at least a list. So I set that constraint and then I continue type checking. And then I can actually type check the whole expression. Does that make sense? Maybe. So I'm interested in trying to see if we can use the same heuristic like in general, so we can just write the code you want to write and then it just type checks. But I'm not sure if that's workable or not yet. So just thought for thought. Okay. And the first that programming thing. Let's talk about macros. So what are macros? Some people may say they're a mistake, or like your wireless strings come true, or just a function from tree to tree. I think a more high-level way to see them is like it's a way to program the compiler. I find that interesting. So briefly, the macro system in Dotty is like there's two layers to it. There's a first layer which is supposed to be safe, which involves quoting and splicing trees. So firstly you have to like do some. So you define your macros in two parts. First, you define a def, which has to be inline, and then it uses these weird $braces things to say, oh, the content of this thing is like a macro that has to be evaluated. And then in the implementation, you have a quoted tree, and using this quoted tree, you write the code that you want to generate, and you just use $exp where you want to splice things in. So it's a bit like string interpolation. Right. So of course, that gets you some of the way, but people do crazy things with macros in Scala. So to get to these crazy things, you need something deeper than that. You need an API over trees. In Dotty, this is called tastier reflect. It's called like that because instead of just exposing the internal compiler trees directly, we define an abstraction. We have an abstraction called tasty, which is a serialization format for Dotty type check trees. But once you have that, basically you've defined every kind of tree you can have and what their meaning is. So we thought, well, maybe we can reuse the same thing to define an API to actually manipulate these trees. And this is what tasty is. Tasty reflect is, sorry. So it's a little bit involved, and I actually now want to go further, and not only do live programming, but do live meta programming. This is where it gets complicated. So, okay. So this is a very, like a basically boilerplate for meta programming, and it's not doing anything interesting. It's just there's a macro, and then it just returns the expression that's taken as input. Okay, and now I want to show something I've been playing a little bit with in the IDE, which is a way to show the type check trees. So I haven't mentioned this before. So say you write list 1, 2, 3 dot map plus 1. You know the compiler is going to do, the type checker is going to do stuff, and as I said, like it's going to add the type parameters, it's going to expand the lambda, but you usually don't see that stuff. So I did this thing where I can press a button, and then the compiler goes and fetch the type check tree for me. Cool. I think that's interesting just to see like what's the compiler view of your code, and you can use it to, for example, see implicit. So you see, oh, Max here takes an implicit ordering of int. You can use it for a bunch of things. What I think is kind of interesting is you can use it for macros. So here I have a macro that doesn't do anything interesting, it just returns its input, so I can evaluate it in the IDE. And then the idea is, well, what if we did more complicated things with our macros? So I'm not going to type all that stuff because it's a lot of boilerplate, and I probably run out of time. But the thing I've been playing with is, let's see. So I'm just using the macro APIs in weird ways, which is why it's like a lot of code. But basically, what I'm trying to do is take advantage of all this information that you have from the macro context and bring that back into the IDE. So the first thing I do is I take the expression, the input. So let's make a more interesting input. So say I have an option of int, and pass it to my macro. And what I'm going to try to do is generate the pattern matching for that on all the cases of the option. So for that, I need to get the class that corresponds to my type option of int, and I get its children, then I get the type of what is children, and then, as I said, you can generate trees with macros. So why not generate a tree that corresponds to the type checked. Let's see that one. Yeah, both it again. But I can do something like that. So I'm doing an enum, which is like the same thing as like a case class, or seal trait with case classes. And the idea is my macro, it's not doing anything interesting as a macro, it's like it's making a pattern match on the value that's passed to the macro, and then it's doing a case for every child class of the macro. But if you expand that, then you get the pattern match of the macro. You have the expanded pattern match of the type. So here color has 3 cases, and we got the 3 cases. And here I even put little type trawls in here. So if I have some expected type, then it's going to tell me, oh, it should be int, it should be int, it should be int. So I think that's a very interesting way to see things. So we can use macros not only to generate code that's going to be run at runtime, but so that's going to be run at compile time to avoid boilerplate, but you can use macros to generate stuff while you're coding. And why the hell would you want to do this? Because refactoring is the pattern matching thing, IntelliJ does that, Methods does that. But here the interesting thing is this is all user defined. This is just a macro. So if I'm a user, a library offer, for example, and I have a specific way I want people to expand my types. Maybe you don't want to use a pattern match, maybe you want to use a fold. Then I could define a macro that does it for me, and then tell people, well, you can use that. So the idea here is user-defined refactorings. Anyone can make their own refactorings instead of relying on what's built into your IDE. There's another interesting use case. Jack Coley, whose name is David Barry, made this project called Mr. Boilerplate, which is interesting. It's a way to, instead of using the CLC macros to do codec generation, so encoders and decoder for JSON, he made a website where you can put your case classes and stuff, and you can say what kind of codec you want to generate, and it writes down the code here. And there's so it's kind of a weird thing, but it makes sense because sometimes you don't want to rely on the macro. So macros have issues like they can be slow, and if you are using some protocol that's something you don't control, then you probably don't want to change that protocol every time you change your case classes. So you want something which is stable. So it makes sense to be able to do code generation. And so with this idea of just expanding the macros, then you can write macros which are explicitly defined to be able to allow you to do that instead of making websites to do that sort of things. All right. So of course there's limitations here. So the main limitation is when I'm doing this expansion, then I have to pretty print the compiler trees, and those are not really nice trees. So if I expand a variable, then it's fine. But if I expand something more complicated, like list.map, then you get all the type parameters and all that stuff. So just taking the output of a macro doesn't produce the nicest code. There's actually another way to do it. And wow, I'm very short on time. But I'll show you the idea. So the idea is, and let's again call the macro, script hello, because I don't have better idea. Okay, so here I'm doing the macro that's again returning just its input, so it's not doing anything interesting, but I also have this apply edit thing in here. And what this does is basically I'm storing in my compiler some information that the IDE can then use. So the idea is I want to do a macro that can send comments to the IDEs. I can't directly send comments to the IDE, but I can store some pre-post comments, and then the next time I run the type checker, I can ask the compiler to send that to the IDE. So here, the command I want to send is an addition. At this position, I want to replace the code at this position by this string. So if I save that thing, and then I click this button. So you see the potential here, right? So the idea is you don't just do macro expansion, you do macros that ask your IDE to do stuff, and you can be wild, you can ask it anything. So I'm really going to run out of time, so I can't show you all the cool stuff I want to show you, but here the main limitation, of course, is that you need some tree to be able to get like the position, to be able to send the comment. But so and normally like macros, like the only tree they see is what they have as input, but we can be crazy with like interactive macros. So I added something called project trees that just returns all the trees in your project. So all the trees from all the source files in your project. And I have another thing called all trees that returns all the trees of all your dependencies that you get from Tasty. So you can potentially do refactorings or stuff like that. So of course, yeah, if I just want to rename 1, 2, 3 to hello, that's not very interesting. But the interesting part is, since I have access to the whole compiler here, I can do type-directed things. So for example, I can do rename all the identifier which are subtype of string and whose name starts with this string by this other string. And then I'm going to skip over some of the other stuff I did, but basically you can do the same thing for completions. So you can define custom completions. Is it very bad if I
don't think so.
over time?
It depends on the people.
Are you tired?
There is nothing else. Yeah.
There's even better with after completions, but just I have this other command which is called set completions, and what this does is it hijacks the completion. So here, if I have to save, oh yeah, so there's a trick here, which is I'm defining the macro in the same file where I'm using it. You're not supposed to do that, but and then if I do, well, there's a shortcut, right slash. Let's see. Yes. So here I get the completion from my macro. So you can define custom completions if you want, and of course, like you can't do everything from macros except if I decide you can, and then I have stuff like all matching implicits to the macro API. So then you can make custom macros that just return all the implicit in scope that match some type, for example, or anything crazy you might want to do. Okay. Okay. So one last thing, because I spent some time on that one, so I think it's worth showing it to you. So, so the interesting things with the completions and references is that I can do that without changing the language server client, because I'm just changing the answer that the language server, the compiler, sends to the client when it asks for completions. But there's some stuff where you might actually do something more complicated than that. So, so there's this thing in VS Code which I find is very interesting, where you can have web views. You can just run HTML. So what if you could have macros that generate HTML, and then you send that HTML to the client to display stuff. So let's see. So can I unzoom? Yes. So this is just a live view of. So you know how I showed you like trees as diagrams. Well, instead of making these diagrams by hand, well, what if we could make a macro that used some beautiful handwritten like SVG and HTML and JavaScript in strings in HTML? Yeah, we could probably do that with ScalaJS if you know ScalaJS. And then as I type stuff, I can just the macro just gets run, and then it sends the string, and then stuff happens. So if I want to know what string, what tree I get for some expression, I can just type it, and then it appears here. So this is where I'm glad that my talk was delayed, because I was not at all ready to show that this morning. And I spent like 2 hours reading the documentation of D3. Anyway, so I think that's pretty cool. I have one last thing. I want to show one more thing. If I remember how to change stuff in this code. To be very careful here. So this doesn't look very exciting, but here I have some expression here with a bunch of constants, and then in my macro I just traverse over the input. So here I'm actually only traversing over the input of the things passed to the macros, and I find all the constants, and I store them in the buffer, and then I write some horrible HTML, that does stuff, and then here as an output I can see all of the constants in my expression, which of course doesn't sound very useful. Let me zoom in. But then I can do that. and this is like 5 lines of JavaScript to basically just, for all my input things, I just store the prepositions, and then I have some JavaScript functions that send a message back to VS Code, which says, oh, please do some apply IDE command that takes the value of my slider, and then send the thing back. So any UI you want, you can do it in JavaScript. How cool is that? Thank you. Some related work. You should all read Type-Driven Development with IDEs, because it's a great book. And the kind of ways they do development in IDEs is like all this approach with like titles and stuff, so it's pretty inspiring. And then there's this thing called elaborator reflection, which is about trying to write stuff in some monad or something to do tactics. So tactics are the usual way people talk about doing code that transforms your code to prove something. And here, like, I'm trying to prove some programs. Anyway, like, check it out. And then there's this thing called Hazel, which is a language where everything you type, the program is like typed holes. So you can put holes everywhere, and then you have something in the side which says like, what are your contexts, how do you fill this hole? And you're supposed to be able to program just by clicking on things without actually like writing strings by hand. Yeah, I think that's it. Q&A. Thank you very much.
There's one amazing thing that just happened in the comments. There was a question about, can you parameterize your macros? And when you showed the last example, there is another comment, skip the question, it doesn't matter anymore. And there is a second thing. There was a question about IDEs, and you just replied on that. So, one more round for applause for that, because it was amazing. I think there's a few other questions. I think we skipped because of the lack of time. That was the only reason. But maybe we can go right now. So, there is this one.
Yeah, there's a tab.
There's a tab?
Yeah, just next to
Oh, yeah.
Yeah.
Sorry.
Maybe you can do it in motion.
So the first thing
Is maybe the first one.
in the horse example, why is the prime reported in the closing bracket of the object and not the closing bracket of the function test? Because I ran out of time. And I mean, even putting it in the closing bracket of a function test doesn't seem very satisfying to me. So I don't know what a satisfying solution actually is. Maybe you want to put it just as a decoration text on the side. Maybe you want to put it on a tree view on the side. Yeah, so I didn't talk about that, but you can have trees in VS Code, right? In the side, on the side thing here, you can have custom views and the are trees. And Metals has this preview protocol to be able to build your custom views, because that's not part of the Server protocol. What extension to VS Code do I need to have Dotty support? You don't need to think about that, because if you go to Dotty example project, tells you everything you need to do, which is basically you clone the repo, you do SBT launch ID, and then it auto-install the extension, which is called the Dotty language server extension, I think. And hopefully metals and metals and the Dotty extension don't conflict with each other, because metals detects when there's the VS Code, the Dotty thing installed and then doesn't start.
I think there's one more.
Can you edit the tasty trees of your library dependencies from the macro API? Why would you do that? No. Because well, there are your dependencies, then well, at some point you're going to run your code, I guess, and so you're going to use the class files of your code. But if you want to do that, you probably want to vendor the dependency, that is like put it in a Git module or something and patch it, and then you could do that. Yeah, I think that's all.
Yeah, I think that's also. I just wanted to remind you that there is a way that you can vote for this talk and ask the feedback. On the slide up, there is a poll active. And that's all for today. This is a really long day. I hope that you learn exciting things. And we really end up in really good and positive notes. I'm still processing what I just said.
Oh yeah, and yeah, I should have said that, but this is all like prototype code stuff I hacked in 2 weeks. So like don't expect that to be in Dotty tomorrow or next year or anymore. Like I don't know where this is going, but I wanted to share this with you and see what you think of it.
And let me tell you a little bit more what's going to happen tomorrow, because tomorrow we don't have any ScalaSphere talks, but instead there is Contributor Summit going. So if anyone is interested in going into talk about Scala community, about Scala ecosystem, about future of Scala, about anything that you feel that is important for our community, we are open to anyone right now. I think we got some spots. And also you can still feel free to join here for the other amazing presentation. There is other spheres going on. Tomorrow I think it will be JS sphere, data sphere, and cloud sphere. So plenty interesting topic as well. If not, Contributor Summit as your option. And have a really amazing evening. And see you, some of you here, some of you on the Contributor Summit tomorrow. Thank you so much.